Good afternoon. Today we're going to talk about using and interpreting an independent sample t-test. I'm sharing my screen. So we have our data. We have reading scores for male and female students. Of course, I separated the scores, individually calculated the means as well, just to have the data. When I completed a t-test pair two sample means, I did it with the male data first. And when you are comparing data, you should start input into the variable one, the highest mean first. So then I went back and completed a two sample means using the female data first because it does have the highest mean. However, it calculated with the degree of freedom with 4, which is the population minus the 1. And when I was running my Cohen's d, and I didn't even do the R squared for this one, the variance, the t-stat score was significantly higher than if you run it as a two sample assuming equal variance. And for me, I just had a hard time computing with that, so I'm back and run a two sample assuming variance. However, if you look at the p-value um, on the two-tailed, there isn't a significant difference in variance. So I went back and I run a Cohen's d, and we're looking to see if my research questions is, do male and female fourth grade students differ significantly in their average reading scores? The population is all fourth grade reading students. The sample size is 10 students, 5 male, 5 female. Fourth grade students. So my hypothesis is that there is no difference between the reading scores of male and female students, and the alternative is that there is a difference between the reading scores of male and female students. Setting the significance level as a greater than or less than 5% difference. Looking at all of the stats, there is, even with the, when I run it there is a significant difference than the 5% if you're looking at the p-value, which is a 0.12. And then if you do it as a two test simple assuming variances, that it's the two the scores are not significantly different. However, when you enter it into the Cohen's d, you can see that if you compare it to the critical values, that there is a difference in the scores. And when you enter into the R scored, you can see that 70% of the scores are higher than the variances can be explained by the differences in the sex. So using my difficulty was determining which Cohen-Dees formula to use. So I did it in one way using the pooled, and then I did it the other just using the degree of freedom. I like the pooled variance better. It was easier for me to see a significant difference, but as an evaluator, I would consider classroom management as contributing to the differences in male and female students. There are research methods supporting the fact that instructional strategies should be aligned the with the percentage of male or female students you have in your classroom, because research supports that there are different instructional strategies to use with male students compared to female students. So as an evaluator, I wouldn't look at there being a difference in ability or where these students are needing intervention. I would use it as a way to determine what type of instructional support your educators need. Because you have a significant male to female ratio of students, you're going to have to structure your behavior management differently, your instructional strategies differently. You're going to have activities that engage the male mind differently than the female mind. And that's coming from some research, just professional development that I have been involved in recently, where they're suggesting that you use different instructional strategies if you have a higher ratio of males, or and then equal it out to suit the students in your classroom. All right. Thank you very much.